I think from my perspective, one of the coolest images of Saturn is the view of the North Pole, where you see that hexagonal structure rotating in the atmosphere. And one of the things that scientists are doing is they're using the evolution of that atmospheric structure to understand how the dynamics of the atmosphere works. Because if you think about it, you can't really get into the atmosphere and make the measurements. But by being able to remotely view the atmosphere and see how the structure changes over time, it allows you to understand the dynamics of the atmosphere. If material is coming up from below, some of the instruments are able to tell you what kind of molecules and material are in the atmosphere.
Now, if we want to put this mission in a historical context, we have to imagine our ancestors who looked up at the sky, saw the constellations of distant stars, and then a handful of small objects that wandered with respect to the distant stars. They were called planets. The development of the telescope permitted us for the first time to see what the planets really were like. Galileo saw what he thought he saw, a planet with ears. And later, Christian Huygens, a Dutch astronomer, found that the planet was surrounded by a disk which nowhere touched it. You can see some of the thousands of small ringlets which surround the planet, a kind of miniature solar system composed of billions of orbiting chunks of ice in size ranging from glaciers down to particles of smoke.
was a real focus of Cassini-Huygens. We've had over 120 flybys of Titan by the Cassini spacecraft. The European Space Agency Huygens probe traveled down through the atmosphere of Titan and landed on the surface.
If we were to find out that right here in our solar system, life started twice, once on Earth, once on Titan, or once on Earth, once on Mars, we found out that life started twice, then we would know that life is common in the universe. It started twice right here. So if we find life on Titan, there's no chance at all that it is on our tree of life, because it's living in a fundamentally different liquid than life on Earth is. And that's why Titan is so fascinating to astrobiology.
Titan is a weird place. So, what would it be like on the surface of Titan? A little bit weird. You know, you've got bits of petrol, liquid petrol lying around on the surface. But also Titan is the only moon in the solar system that has a dense atmosphere. My favorite moon is Enceladus. The moon that my team discovered a water vapor plume at. You know, when people get excited about the potential for life elsewhere in the solar system, there are 4 things that you need. You need a heat source, you need liquid water, you need organic material, and you need those 3 things to be stable over some period of time so that life could potentially form. At Enceladus, we've got 3. I'm not sure about the stability over time yet.
If you see Dione, you'll notice that most of the surface is pretty bland. And only in this one region, near the trailing hemisphere, do we see a lot of detail on the surface. Here we see a lot of crisscrossing faults with wispy bright markings around them. In the case of Mimas, we see a crater on Mimas that's about 40% of its diameter. A little larger, and that would have been enough to shatter the object. And of course we wouldn't see the crater then, because it would reassemble like a kind of a giant ball of sand.
Here is a view of an astonishing icy kind of moon called Tethys. You can see this enormous valley, which runs essentially half the length of the object, which has been called Ithaca Chasma. You can faintly see a vast impact basin, and here you can see that basin, which has multiple rings and looks like some of the Maria on the moon.
This is the moon Hyperion. It's 250 kilometers across, so that's about a quarter the size of Dione, so about a 12th the size of our moon. This is looking like something taken out of the ocean. It looks like a big sponge. We know why it got this way. It has to do with very low porosity of this moon and low gravity, so that when impactors hit it, any material is just lost and doesn't come back and coat the moon.
The outer solar system is filled, Ted, with junk, debris, things the size of a house to the size of a small moon. Exploring the solar system gives us other worlds to compare our own with, to better understand and control our own planet.
Atlas also has carved a gap in these. Pan, as you can see, carving a gap in the rings. Beautiful little moon Daphnis is running around in the Keeler gap, and you can see the waves of gravitational dispersions that is put on the rings.
Think of the remarkable achievement. For 4.5 billion years, things fall on the Earth, like those impacting meteorites, nothing leaves it. Suddenly, in the last 20 years, a set of tiny golden spacecraft go off in all directions to examine every one of those ancient points of light that our ancestors called planets. For the first time in human history, we have examined close up these other objects and discovered them to be worlds awaiting future exploration.
It's there. Voyager 2 has reached Saturn after 4 years in space. It got there just a bit early, 2.7 seconds early to be exact, after a flight of 1.25 billion miles.
Human beings are in the exploring business. That's what we're good at. We enjoy the sense of exploring. We are exploring the deepest questions that every human culture has asked, questions of origins. In this case, where did the Earth come from? Where does the solar system come from? Where do we come from?
3, 2, 1. We have ignition and we have liftoff. We have liftoff of the Titan Centaur carrying the first of 2 Voyager spacecraft to extend man's senses farther into the solar system than ever before.
There will be a part of Earth which will roam essentially forever in the galaxy, and that will be the Voyager spacecraft.
After the Voyagers went by Saturn in the early 80s, it became very, very clear that the world needed to go back. The Cassini-Huygens mission was an international venture right from its very conception. It was proposed by a small team of international scientists. It was accepted by an international congress of planetary scientists, and then implemented by 3 space agencies, 19 member nations, hundreds of international contractors, and thousands of scientists and engineers. It took 15 years for that consortium to get from concept to launch, and another 7 years to get to Saturn.
There is a pumping of high technology, for example, in robotics, which has applications to many other practical aspects of life on this planet. It is an enterprise which is peaceful, which is on behalf of the entire human community, and which will be remembered for thousands of years. It is by far a bigger step than Columbus's discovery of America. The exodus of human beings and their robot emissaries to explore their local swimming pools.
1. And liftoff of the Cassini spacecraft on a 30-mile trek to Saturn. This program is in. The Cassini spacecraft is on its way to Saturn. Plus 20 seconds. All systems are go.
The Cassini spacecraft, an emissary from Earth, was screaming over Saturn's North Pole. Cassini was on a collision course with the planet. Its termination was inevitable. A one-way trip for the spacecraft. It became a part of the very planet it was sent to explore.